Students, welcome back to the class. So now we are going to discuss some of the important questions completely related to the topic organic chemistry. So under this, we are going to learn about hydrocarbons as well as biomolecules, part 2. Okay, we will discuss some of the important questions related to this topic today. So here we have the first question. An organic compound is a clear liquid having a molecular formula C4H8O. It has an open chain structure without any carbon-carbon double bond. The compound can be an alcohol, an ester, an aldehyde, a ketone. Option A and B. Option B, C and D. Option C, B and D. Option D, D and A. Okay, now let us look at the answer here. So the right option is option C and D. That is option B, C and D. So here it is an aldehyde. Okay, the compound that we have here, it could be an aldehyde or it could be ketone. Okay, let us understand that here. So we have given, okay, they have given us this formula, molecular formula of a compound. And here the compound is very clear liquid. Okay, and they also given that so it has an open chain structure without any carbon-carbon double bond. There is no any double bonds present between the carbon atoms. Okay, but now what could be the compound? So that we have to find it out here out of the given options. So an organic compound of molecular formula C4H8O. That means here we have the general formula for the same. Okay, C4, N is equal to 4. So if you substitute this is the one that we will get, right? So it could be, so here the general formula of this molecular formula that we have here is CnH2nO. So it is also given that there is no any double bonds present between the carbon atoms. So definitely it cannot be alcohol, because if it has to be an alcohol, there should be alcoholic, that is a hydroxyl group, which has to be connected to one of the carbon group. Okay, so since there is no hydroxyl group present between the carbon and carbon alcohols, carbon and carbon atoms in this, so it cannot be alcohol. Okay, so we cannot consider this first option now because there is no double bonds present. Clear? So now when we are looking at this esters, so it cannot even be ester, because for a compound to form an ester, there should be 2 number of oxygen molecules. Okay, there should be 2 oxygen atoms. So only then we can consider the same as an ester. But since there is only 1 oxygen atom present here in this compound, it cannot even be ester. Now the possibilities are, okay, the final compound, there are 2 possibilities. One thing, it can be an aldehyde or it can be ketone, where both of this aldehyde and ketone, they have this general formula CnH2nO. So that is what we have here. Okay, so both this aldehydes as well as ketone have the same general formula, so which is equal to the same given molecular formula of this compound. Okay, so the right option is aldehyde or the ketone. Moving to the next question now. Which one of the following elements forms highest number of compounds? Oxygen, hydrogen, chlorine, carbon. Okay, let us look at the right answer. Here the right answer is option D, carbon. Okay, carbon is the one. It is one of the element which can form highest number of different compounds. It will combine with different elements here. Some of it will be metal and some of it will be non-metal to form a compound. Okay, so they usually combine easily to form a compound. So what is the necessary of it? How it can form easily compound? So carbon elements, okay, these carbon elements forms highest number of compounds when we are comparing it with that of the rest of the compounds, rest of the elements that we have in these options. Okay, because it is one of the 15th most abundant element which is present on earth crust. So when we are comparing it with that of the rest of the elements, here carbon is most of the quantity of this carbon is present in our earth crust. So apart from that, even this carbon, since it has a 4 valency, right? The valency of this carbon atom is 4. So it can provide a space for different atoms here. So 4 different atoms can combine and occupy the space of this valence electrons. Okay, valence atoms where there is a space here. So since there is a 4 valency here in the carbon atom, 4 different atoms can come and occupy the space of it. Okay, so that it can form 4 different compounds. So easily it can form the different compounds. So it's all because this carbon has a right and very small size so that it can easily fit into the larger, bigger molecules. Okay, if there is a large molecule, so here in a small space itself, this carbon atom can easily fit in. It's all because of its nature, physical nature. Okay, moving to the next question now. Which one of the following substances is used in the manufacture of safety matches? Red phosphorus, white phosphorus, phosphorus trioxide, black phosphorus. Okay, let us look at the right answer here. The right answer is option A, red phosphorus. Okay, red phosphorus is the one which is used here in the manufacturing of safety matches, the matchsticks that we use, right? So here the red phosphorus that you can see here, which is that is the one which is used here in safety matches. Okay, it is the most commonly used in the manufacturing of safety matches as well as in making smoke bombs. Okay, to produce the smoke. So there in the smoke bombs, this red phosphorus is the compound that is used. Okay, moving to the next question now. Match column 1 with column 2 and select the correct answer using the codes given below. Column 1 and column 2, here we have carbon, unsaturated hydrocarbons, CnH2n, conductor of electricity, graphite, allotropy, ethyl alcohol, fermentation of molasses. So here we have the options. Option A tells us that A we have to match it with P, B with R, C with Q and D with S. So A with R, B with P, C with Q and D with S. Option C tells us that A with R, B with Q, C with P and D with S. Option D, A with R, B with P, C with S and D with Q. Okay, let us look at the right answer here. So the right answer is option B. A with R, B with P, C with Q and D with S. So now let us look at this here. So carbon, here we have under column 1, we have carbon. Carbon has different allotropic forms. Okay, that is basically they are available in the form of graphite and diamond. Graphite and diamond, these two are the crystalline allotropes of carbon, element carbon. What is this allotropes? It is one of the phenomenon of existence of this chemical element. So here we have this chemical element called carbon, right? So this carbon exists in 2 or more different forms, different with their physical properties, but having almost same chemical property. Chemical property will be the same, but the physical property usually differs. Okay, that is what we call it as allotropic forms. And even similarly here, carbon is one of an element, most known element, right? So even this element also exhibits allotropic forms. That is, chemical nature will be the same, but physically they will be usually different. There will be a difference. Okay, they differ in their physical properties. So carbon, the allotropic forms of this carbon is graphite and diamond. These two are the most known crystalline allotropes of carbon. Okay, so next we'll look at this next option. So CnH2n, it is one of the unsaturated hydrocarbon. Okay, CnH2n, it is a general formula of alkenes. Alkenes are one of the unsaturated hydrocarbons, aliphatic hydrocarbons. Okay, moving to the next one here, graphite. Graphite is good conductor of electricity. So here graphite is one of an allotropic form of carbon. We know that carbon is non-metal. Definitely even this graphite is also non-metal. Even though it is non-metal, it can conduct electricity. Okay, so graphite can conduct electricity. So this is one of the non-metal which can easily conduct electricity because there are free mobile electrons which are present here in this graphite. So which are responsible for the conduction of electricity. Okay, next here we have ethyl alcohol, which is also known as ethanol. So this ethanol is formed because of the fermentation of molasses. Okay, when we ferment this molasses, finally we will get this ethanol, one of a form of alcohol. Okay, so this molasses, these are the byproduct of sugar industry. In sugar industry, one of the byproduct obtained here is molasses. So even definitely they too have traces of sugar within that. Okay, so this molasses will finally get broken down into ethanol by the action of enzymes. Okay, when there is an enzyme present, it can easily convert this sugar traces into alcohol. Sugar which is getting converted into alcohol, that is what we call it as fermentation. Okay, fermentation is a process of conversion of sugar into alcohol. So now the fermentation in this process is initiated by the yeast. Okay, yeast is a one which is a major, it acts as a catalyst to carry out this fermentation reaction. Okay, so which is the one which is helpful here in the formation of ethanol. So now the yeast which is present here in this molasses will convert. Okay, it will produce two different enzymes called invertase and zymase. So with the help of these two enzymes, finally the ethanol, that is ethyl alcohol, is formed. It is one of an alcohol. So, and it is completely exothermic reaction. This reaction, that fermentation process is exothermic. That is, it will also liberate heat energy to the surrounding. Along with that, it also liberates carbon dioxide gas. So when there is a release of carbon dioxide, then we can say that there will be definitely a fermentation process would have taken place, right? Now let us look at the process here. So here we have. So first we have, if we are taking the sucrose is a salt. Sorry, it is a sugar, basic sugar, disaccharide sugar, which is present in the sugar cane, right? Sucrose, C12H22O11, which is nothing but sucrose. So when we are adding water to this and in the presence of yeast, which will usually release this enzyme invertase. Okay, invertase. So by the action of this enzyme invertase, now the sucrose is converted into glucose and fructose. Now, if we are considering any one out of it, that is glucose or the fructose, now the next enzyme, which is zymase, which is present here in the process of fermentation, zymase, because of the action of the zymase, here the glucose or the fructose is then converted into ethanol, ethyl alcohol. Along with the formation of this, one of the byproduct released is carbon dioxide gas. Okay, carbon dioxide gas is released here. So by this fermentation process, ethanol is produced. Okay, moving to the next question now. Which one of the following glasses is used in bulletproof screens? Soda glass, Pyrex glass, Gina glass, reinforced glass. Okay, let us look at the right answer here. The right answer is option D. Yes, very good. So it is right. The right option here we have is reinforced glass. So this is the one which is used here in making bulletproof screens. So here the soda glass that we have here. Okay, soda glass, which is used in window panes. In the manufacturing of window panes, there they will use the soda glass. And Pyrex glass, it is used, so there will be presence of borosilicate here in this Pyrex glass, which is responsible, which is required to make laboratory instruments, that conical flask or burette pipette, beakers, test tubes. So all of these that we will use it there in the laboratories, there we require this Pyrex glass. So using this Pyrex glass, all the laboratory instruments are made. Gina glass. So Gina glass is used in the manufacturing of thermometer. The thermometer, different types of thermometer, clinical, laboratory, or minimum, maximum thermometers. So all the thermometers, it is basically made out of Gina glass. So now here we have reinforced glass. So here in this reinforced glass, there is a presence of steel wire mesh inside it. Okay, if this is a layer of the glass, so inside this layer of the glass, there is a presence of steel mesh. Okay, steel wire mesh, which makes it stronger, which makes the glass stronger. And sometimes in some of the case, it also acts as fireproof. So even the bullet, if there is a bullet attack, if we fire it, so nothing will happen to this glass. So we can use this reinforced glass in bulletproof screens. Due to the presence of steel wire mesh, it will usually protect us. Moving to the next question now. Which of the following do not contain nitrogen element? Superphosphate of lime, urea, Indian saltpeter, shell saltpeter. Okay, now let us look at the right option here. The right answer is, so yes, we have the options here. Let us look at this now. So option A tells us that 1, 3, and 4. Option B, 1 and 3. Option C, 1 only. And option D, 3 only. Okay, let us look at the right answer. The right answer is option C, 1 only. Because the superphosphate of lime is not used as nitrogen. Okay, it is not used here. It doesn't contain nitrogen element. Okay, superphosphate of lime does not contain nitrogen element. So this is the option that we can choose out of all of this. Because urea, Indian saltpeter, chili saltpeter, all of this consist of nitrogen element. Let us look at this molecular formula of each of this now. Superphosphate of lime. Okay, superphosphate of lime, which is also known as, the chemical name of this is monocalcium phosphate. Okay, monocalcium phosphate group that we have here. So it doesn't contain any nitrogenous element here, right? In this compound, we cannot find the nitrogen. Next here, urea. Urea definitely it has nitrogen, right? Carbamide. So this compound name, chemically we call it as carbamide. Next, Indian saltpeter, which is also known as potassium nitrate, right? Nitrogen element is present even in this. So chili saltpeter, sodium nitrate, even nitrogen is present even in this. Okay, so in all of this compound, there is a presence of nitrogen element, but not in the superphosphate. Okay, so here the urea, Indian saltpeter, chili saltpeter, all of these three are added in fertilizers, in the manufacture of fertilizers which are required for the growth of the plant. Okay, urea is the one most commonly used. When we are looking at the superphosphate of lime, okay, superphosphate of lime is used as leavening agent. Leavening agent there in baking industry, usually in the preparation of bread, or pastries or even the cake. So their leavening of the medium is necessary, right? If there is, so this media, it has to be leavened, the topmost layer. So here too, as a leavening agent, here superphosphate of lime is added in baking industries to bake the food. Moving to the next question. Red phosphorus is used in the manufacturing of safety matches. This is due to the fact that it shows phosphorescence. At ordinary temperature, it is less reactive than other various varieties of phosphorus. It cannot be converted into white phosphorus on heating. It does not react with halogen on heating. Okay, let us look at the right answer here. The right answer is option B. At ordinary temperature, it is less reactive than other varieties of phosphorus. So when we are using this red phosphorus in safety matches, okay, at ordinary temperature, it will not usually catch fire. But what actually happens when we are increasing the temperature here? Okay, basically this phosphorus is of two different types, white and red phosphorus. Okay, this white phosphorus is highly reactive even at room temperature. Even if we are placing this white phosphorus at room temperature, it can catch fire. Okay, it catches fire at room temperature, but this red phosphorus does not show any such reaction. But when we start striking this matchstick, so there is a presence of red phosphorus at the end of this matchsticks, right? So that was initially, so very longer time, that is what they were using. The end of the matchstick, it was filled with red phosphorus, and now, so in nowadays we will usually paste it here at the sides of this matchbox itself. Okay, they will apply this red phosphorus here itself along with the mixture of glass pieces. Okay, glass powder actually. So now when we strike this matchstick on the surface of this hard surface, when we are striking this on the rough surface, usually due to the friction, heat is generated, right? We know that friction is exothermic in nature. Due to this, heat is liberated, and at this increase of temperature, the red phosphorus that we have here will get converted into white phosphorus. When this red phosphorus converts into white phosphorus, so it attains ignition temperature and catches fire spontaneously. Okay, so that is the reason red phosphorus is basically used here in safety matches instead of white. Moving to the next question. Which of the following statements are usually correct for carbon compounds? These are good conductors of heat and electricity, or poor conductors of electricity. They have strong forces of attraction between their molecules. They do not have strong forces of attraction between their molecules. So here we have the options. Option A and C. Option B, B and C. Option C, A and D. And option D, B and D. Okay, let us look at the right answer here. The right answer is option D, B and D. Okay, let us look at these two statements, B and D. So these two are the correct statements for carbon compounds. So the statements tells us that carbon compounds are poor conductor of electricity. And also they do not have strong forces of attraction between their molecules, right? Because these carbon compounds are covalent in nature. That is, so they usually share the electrons between themselves. Okay, partial sharing of electrons between the atoms. So that is what is this covalent nature, and that can be found here in the carbon compounds. And because of this covalent nature, they are poor conductor because they cannot completely take in the electrons. It is only a partial share between the atoms. right? So they are poor conductor of electricity and do not also have the strong forces of attraction. So the attraction between the atoms here in the compound, it is not stronger enough. Okay, the carbon element, the atoms present here doesn't have stronger forces in between them. Got it? So when we are looking for this carbon compound, these two are the right statements. Clear? Moving to the next question now. Biogas mainly consists of carbon dioxide and hydrogen, hydrogen and methane, carbon dioxide and methane, hydrogen and oxygen. Okay, let us look at the right answer here. The right answer is option C, carbon dioxide and methane. Okay, so here in the biogas, the major component present here, okay, it majorly consists of this carbon dioxide gas as well as methane. So primarily a mixture of methane. So here we have this molecular formula CH4 and inert compound, okay, inert gas, that is carbon dioxide, which is present here in this biogas. And the gas is produced because of the anaerobic digestion or the anaerobic fermentation of organic matter. So when this organic matter, when it gets converted into, right, the agricultural waste or the manure or sewage, sludge, municipal, solid waste, biodegradable waste, we know that all of this, when we mix it in the soil, it will get biodegraded, right? Due to this anaerobic digestion, anaerobic fermentation, which is caused because of a bacteria, soil bacteria, decomposing bacteria there. So which is the one which will finally convert it into biogas. Okay, it is a clean as well as renewable fuel. Clear? So the right option out of all of this is carbon dioxide and methane. These are the mixtures which are present here in biogas. Moving to the next question. Low visibility during cold weather is due to formation of fossil fuel, unburnt carbon particles or hydrocarbons suspended in air, lack of adequate power supply, none of this. Okay, let us look at the right answer. The right option here is option B. Unburnt carbon particles or the hydrocarbons which are suspended freely in the air. So that is the reason for the low visibility during cold weather. Okay, so when we are looking at this, so here we can see that smog, right? Smog is the dark brown or grayish smoky mist that occurs during cold weather. And it is a visible indication that there is a cause of air pollution, right? If there is a smog, we can easily tell that it is all because of the air pollution. Now, smoke not only reduces the visibility, we cannot see that clearly there, right? Even if the sun even though it is rising, so the clearance, we cannot even see that clearly what is actually there in front of us, right? It's all because of the air pollution. Okay, here it also reduces the visibility, but along with that, it is highly suffocating and harmful to human beings, animals as well as plants. Okay, if we are breathing the same polluted air, it is suffocating. We cannot breathe that, which can lead to several health issues, lung diseases. Okay. So that because of air pollution here. So here in the smog, there will be unburnt carbon particles. If this unburnt carbon particles, which are released due to the automobile combustion of fossil fuels, definitely that can lead to formation of smog. So which is a visible indication of air pollution. Okay, if this unburnt carbon particles present in the atmosphere, so that indicates air got polluted. Moving to the next question. The following question consists of two statements. One labeled as assertion and the other is reason. You are to examine these two statements carefully and select the answers to these items using the codes given below. Assertion: though carbohydrates are covalent compounds, they are soluble in water. Reason: compounds which form hydrogen bonds with water are generally soluble in water. So both assertion and reason are individually true, but reason is the correct explanation of A. Both A and R are individually true, and R is not the correct explanation of A. A is true, but R is false. A is false, but R is true. Okay, let us look at the right answer here. The right answer is option A. Both A and B, okay, sorry, A and R, assertion and reason are individually true, and R is the correct explanation of this assertion. Okay, let us know that here. So the carbohydrates that we have here, okay, carbohydrate is a sugar component, right? It is one of a nutrient which is present in the food that we have. These carbohydrates such as simple sugars, right? Just like fructose, glucose. So all these are simple sugars and are covalent compounds. So these simple sugars are covalent compound, but still if it is dissolving in the water, because it can form the hydrogen bond with that of water molecules. So any compounds, if it can form the hydrogen bonds with that of the water molecules, then it will get easily dissolved. Okay, since this carbohydrate can also form this hydrogen bonds with that of the water, because they have this low molecular weight. Okay, they are able to dissolve there in the water. Got it? So both the statements are individually true now. Moving to the next question. The compound C6H12O4 contains 22 atoms per molecule per mole, twice the mass percentage of hydrogen as compared to that of the mass percentage of carbon. 6 times the mass percentage of carbon as compared to the mass percent of hydrogen, thrice the mass percent of hydrogen as compared to the mass percent of oxygen. Okay, now let us look at the answer here. The right answer is option C. So here the compound C6H12O4. This contains 6 times the mass percentage of carbon as compared to that of the mass percent of hydrogen. Okay, let us look at this now. So here all the molecules, okay, all the atoms, there is a presence of 1 mole entities. So in 1 mole entities of any of the atom that we take for that matter, so it consists of 6.022 into 10 to the power 23 entities. That is Avogadro number. Okay, Avogadro number, it is common for all the atoms. So now when we are looking at this atomic mass of carbon, right? Atomic mass of carbon is 12 and atomic mass of hydrogen is 1. Atomic mass of oxygen, that is 16. We already know this, right? Atomic mass of each of these elements. And now we have to find out the molecular mass of each of this. So now the molecular mass of this carbon is 6 times to that of the 12, because here we have 6, right? 6 into 12. Atomic mass of hydrogen, that is 12 into 1. So now the molecular mass of this oxygen is 4 into 16. So when you are calculating all of this, we will get 72 plus 12 plus 64. And if you combine all of this, finally we will get 148. So that is the total molecular mass of the compound. Okay, so here we have the molecular mass of each of this elements here, but when we are looking at the compound, the total molecular mass of the compound is 148 moles. Okay, now we have to find out the mass percentage of each of this. How to find it out? Mass percentage that we will get when we are dividing mass of the element by molecular mass of the compound. Okay, mass of each of this element that we have here divided with the total molecular mass of the compound. So now when we are looking at the mass percentage of the carbon, so here we have 72, that is the molecular mass of the carbon divided by total molecular mass of this compound that we have here. So if you're calculating this, we will get approximately about 48.65%, that is 49%. Similarly, mass percentage of hydrogen, that is 12. Here we have 12 divided by 148. We will get 8%. Okay, 8.11%, approximately 8. So mass percentage of oxygen, 64. Here we have 64 divided by 148. So approximately we will get around 43.24%, that is 43%. Okay, so when we are looking at all of this, so now here we have this answer, 6 times the mass percentage of carbon as compared to that of the mass percent of hydrogen. So when we are looking at this carbon and hydrogen, okay, at the mass percentage of each of this element here. So here we have carbon and here we have hydrogen. So if you are multiplying this mass percentage of hydrogen 6 times, okay, if we multiply this mass percentage of hydrogen, that is 8 into 6. Okay, 8 into 6, we will get it around 48, right? So the mass percentage of carbon is also 48.65. That is the mass percentage of carbon. Okay, so we can choose this option. Let us move to the next question now. Consider the following statements and select the correct code. Assertion: the main constituent of liquid petroleum gas is methane. Reason: methane can be used directly for burning in homes and factories when it can be supplied through pipelines. So option A, both A and R are true, and R is the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, but R is false. A is false, but R is true. Okay, let us look at the right answer here. The right answer is option D. Okay, A is false, but R is true. So this statement is not true. But the second statement, that is reason, is true here. Okay, LPG, it basically consists of propane, propylene, butane, and butylene. Okay, the major components, the various mixtures present in the LPG, liquid petroleum gas. It is, so they are propane, propylene, butane, and butylene. So there is no any presence of methane. Methane is not actually present in LPG. It is actually present in CNG, that is compressed natural gas. There we have this major component, methane, but the major component present in LPG is propane. Okay, and all of these are gases. These gases are present at normal temperature and pressure. So standard temperature and pressure. So all of these different gases are found here in LPG. So by this we can say that, so liquid petroleum gas, it doesn't contain methane. So the first statement, the assertion, is completely false. So when we are looking at the reason, this statement, second statement, methane, it is a chemical compound with formula. Chemical formula is CH4. CH4, it is nothing but methane. When we are compared with that of the rest of the hydrocarbon fuels, this methane burns completely. And even though it is burning completely, it will not usually leave out any unburnt carbon particles. Okay, it undergoes pure combustion by producing less amount of carbon dioxide from each unit of heat released. Okay, when we burn this methane, it completely burns without leaving any much residues. Even though if it is leaving the less amount of carbon dioxide into the atmosphere, so it doesn't pollute the city much. So in many of the, so because of this reason, because it doesn't cause much air pollution, so comparatively when we are looking at most of the other hydrocarbon gases, methane is the one which is comparatively better for our usage. So nowadays, to protect our city from air pollution, so most of the houses, even in industrial purpose, even in automobiles, there they will use this methane as a fuel, hydrocarbon fuel in the form of CNG, compressed natural gas. So in many of the cities, methane is piped into houses for domestic heating as well as cooking purpose. So using the same, instead of LPG, we can use the CNG, which consists of methane, and that is actually good for our environment, which will reduce air pollution. Okay, so methane is available in the form of compressed natural gas, which is used also as a fuel, vehicle fuel, automobiles. So methane is also used in industrial chemical processes. There in the production of hydrogen, methanol, acetic acid, acetic anhydride, and also used as fuel in factories. Okay, to run the machines, methane is also used as a fuel. Along with that, in the production of hydrogen, methanol, acetic acid, acetic anhydride, the basic component used in industries are the methane. Okay, methane is the one which is basically used there. Moving to the next question now. Which is true about natural gas? Its main component is methane and is used as a fuel in motor cars. It is used as a raw material for manufacturing fertilizers. It is used for the generation of electricity. It is an inexhaustible natural source. So option A, B and C. Option B, C and D. Option C, D and A. Option D, A and B. Okay, let us look at the right answer. The right answer is option A, B and C. So all of these statements, A, B, C statements are true according to this natural gas. Okay, natural gas, it consists majorly of methane, as I was telling you, right? So methane is the major component present here in the CNG, that is compressed natural gas. The natural gas, it is usually compressed to store it. So along with other hydrocarbons in minor quantities, but the major component here is methane. So this CNG is used as a fuel in cars, buses, as well as the rest of the automobiles. So natural gas is a major feedstock. So this natural gas, it is a major feedstock where there is a presence of methane, feedstock for the production of ammonia. So now we know that ammonia is used as a fertilizer there in agricultural processes, right? Agricultural practices there, as a fertilizer, we will use this ammonia, which is required for the well growth of the plant, right? Apart from this, natural gas is a major source of electricity generation. So this methane, which is present here in this natural gas, is used as a source for the generation of electricity because it burns very clean without leaving much polluted unburnt particles into the atmosphere. Okay, even though it is leaving out, so it will be very less number of carbon dioxide per unit energy. Okay, for every unit energy that it is going to release, the heat that it is going to release, there will be very minimal content of unburnt carbon particles because this natural gas burns very clean compared to that of the rest of the hydrocarbon gases. Okay, hydrocarbon fuels here. So this can be used for various purposes then. Moving to the next question. The order of appearance of the following with increasing temperature during the refining of crude oil is kerosene, gasoline, diesel, gasoline, kerosene and diesel. Option D, gasoline, diesel and kerosene. Okay, let us look at the right answer here. So the right option is option C, gasoline, kerosene and diesel. So let us know about this here. Petroleum products. So when we are refining this petroleum in petroleum refinery, that is from the earth crust, we will get this in the form of crude oil. To get the petroleum, there is a mixture of petroleum product in this crude oil. While refining this in petroleum refinery, the different byproducts at different stages that we will get it here. Or they usually can be grouped into different categories. We can basically group them into 3 different categories. The first here is light distillates, middle distillates, heavy distillates, and residum. So out of all of this, so here in the light distillates, here we will get at the first initial stage itself, we will get this LPG. Okay, while separating this crude oil is a mixture that we will get it in earth crust. So once we take it out, okay, once we extract this crude oil, we have to refine it to separate all the different fuels, right? During this separation process, we can separate it at 3 different stages. So here under the first category, that is light distillates, there we will get LPG, gasoline, as well as naphtha. Okay, all these are petroleum products. And in the middle distillate, that is second refining process, there we will get kerosene as well as diesel. And the third one, that is heavy distillates, which will usually settle down at the bottom of the furnaces, okay, bottom of the purification machines. So along with that residum, so which will usually settle down at the bottom of the beaker because of their heavy density. So heavy fuel oils, lubricating oils, wax, asphalt, all of these are usually heavy distillates. So by this we can say that looking at all of the options that we have here, so when we are writing it in terms of increasing temperature, so here we have the first one, that is gasoline. Okay, gasoline can be the first one, followed by kerosene and diesel. Okay, so this is how by increasing temperature, we will get each of these products. Okay, moving to the next question now. Petroleum gas is a mixture of ethane, propane and butane. Which is the major constituents? Ethane, propane, butane, all 3 as are present in equal proportions. Okay, let us look at the right option. The right answer is option C, butane. Okay, butane is the major component of this petroleum gas out of all of this. Okay, ethane, propane and butane. Out of all of this, butane is the major component present in petroleum gas. Okay, the butane which is present here, it can burn Okay, it can burn very easily and gives off lot of heat energy during this process. During the combustion, it releases lot of heat. Okay, that can be utilized to carry out the different activities for which we are actually using it for. Along with that, butane can be easily liquefied. We can convert this gas into liquefied form under high pressure. So usually gas particles, whenever we are applying more and more pressure to that, it will get converted into liquid because it will get compressed, all the gas particles. If we have a beaker here, since it is a gas, all the particles will be under free motion, right? But if we are applying pressure here, if we are compressing this part, and if we compress it further down, so if we try to compress it as much as possible at this point, so all the gas particle will get converted into liquid part, okay, liquid state. So this is how we can convert even butane into liquid butane under high pressure when we are applying more pressure to that. Moving to the next question. Which of the following statements with regard to Portland cement are correct? Silica imparts strength to cement. Alumina makes the cement quick setting. Excess of lime increases the strength of the cement. Calcium sulfate decreases the initial setting time of cement. Select the correct answers using the code. Option A, 2 and 4 only. Option B, 1 and 3. Option C, 1, 2 and 4. Option D, 1 and 2 only. Okay, let us look at the right answer here. The right answer is option C, 1, 2 and 4. Okay, so these are the right statements according to this Portland cement. So here in this Portland cement, there is a presence of silica, alumina, as well as calcium sulfate. So what is the role of the silica, alumina, and calcium sulfate present? Okay, Portland cement, it is a building material. Okay, cement is actually used here in building material. The main components present here are silica, alumina, and calcium sulfate. Here the alumina that we are adding, so it is the one which is responsible for fast setting. It increases the rate of setting of the cement. Okay, along with that, the silica that we are adding here, silica component which is present in the cement, it provides the strength to that of the cement. And the calcium sulfate, okay, the calcium sulfate which we are adding, it minimizes the setting time. So if there is no calcium sulfate, usually it will take very longer period of time to set, the cement to set. So here when we are adding this calcium sulfate to this cement, it increases the rate of setting. Okay, that is, it will minimizes the setting time. Alumina is the one which is increases the setting rate. Okay, yes. And here when we are looking at the third option, that is excess of lime increases the strength of the cement. Usually even in minor case, so that is in most of the case, minor amount of this calcium oxide, that is lime, is also calcium carbonate. Actually, calcium carbonate is the one which is actually used here in the cement for setting. Okay, it is the one which acts as a binder. Cement particle has to get settled with each other. It has to bind with each other. For that, lime is the one which is actually used. Okay, it doesn't increase the strength. Instead, it acts as a binder here. Moving to the next question. Which one of the following polymeric material is used for making bulletproof jacket? Nylon 66, rayon, Kevlar, Dacron. Okay, let us look at the right answer. Here, the right answer is option C, Kevlar. Okay, Kevlar is one of the part. Okay, para-aramids. Okay, para-aramids. So here, bulletproof vest. Okay, bulletproof vest. So these are made out of polymers. Here, the polymer is called as para-aramids. Okay, here, aramids are the strong fabric. So this strong fabric is the one which is used in making bulletproof jackets. So basically, what is the property of this armids then? It has to be so strong. It has to not allow the bullets to enter in. So definitely it has to be so strong, because this armids which can endure a lot of force before tearing. It can retain, it can resist the force. Okay, it can resist before tearing because it can retain the force there. Okay, it can protect the cloth so that it is used as a bulletproof jacket in the manufacturing of bulletproof jackets. So here when we are looking at this aramids, so it is of two different types, Kevlar, okay, Kelvar as well as Twaran. Kelvar and Twaran. So these two are the one which is basically used in making bulletproof jacket, because this is the one which are usually strong fabrics and they can endure lot of force before tearing. Before the jacket tears, it can endure the force and it can resist the bullets to enter inside the jacket. Okay, so these are the suitable materials to make bulletproof jackets. Moving to the next question. Match list 1 with list 2 and select the correct answers from the codes given below. So here we have potassium bromide, fertilizer, potassium nitrate. Under list 2, we have photography, potassium sulfate, bakery, monopotassium tartarate, gunpowder. So option A, 2413. Option B, 2431. Option C, 4231. And option D, 4213. Okay, let us look at the right answer here. The right answer is option A, 2413. Now let us match all of this with your list with the list 2. Let us look at this now. Potassium bromide is the one which is used here in photography, because to fix the negative, it acts as a restrainer in black and white photographies. Okay, in the black and white photos, usually it acts as a restrainer. That is the reason potassium bromide is the one of a compound which is used here in photography to fix the image there in negatives. Along with that, so it is also used in gunpowder. Okay, here potassium bromide, so next we have potassium nitrate. Okay, so potassium bromide is used here in photography. Potassium nitrate, it is used here in the manufacturing of gunpowder. Gunpowder basically consists of this potassium nitrate. Okay, this gunpowder we also call it as black powder, because it is a mixture of sulfur, charcoal and potassium nitrate. Basically these three are the compounds. In the previous class itself we have discussed about this. These three are the compounds which are present here in gunpowder. Okay, here the sulfur as well as powdered charcoal, these two acts as a fuel, but potassium nitrate, which is present here in this gunpowder, it is the one which is acting as an oxidizer. Okay, to attain the ignition temperature and to catch the fire, potassium nitrate is the one which is required. Clear? Okay, now when we are looking at this potassium sulfate is the one which is used in fertilizers, in the manufacture of fertilizers, which is required for the growth of the plant, because these are the one which are necessary for the growth of the plants. Okay, potassium and sulfur in a compound form, it is added to the plant, the soil. So now the last option, monopotassium tartarate. Monopotassium tartarate is basically used here in bakeries, because in the bakeries they will usually bake the cake as well as bread. So to this they will add baking powder, baking soda as well as baking powder. To manufacture this baking powder, along with baking soda, they will add this monopotassium tartarate. Okay, baking powder, baking soda and baking powder. Here in the making of this baking powder, monopotassium tartarate is the one which is artificially added, which will usually enhance the taste of the food. Clear? Okay. So potassium sulfate primarily used as night fertilizer. So your monopotassium tartarate used in bakeries. Got it? Now moving to the next question. So along with that, here in baking industry, so when we are adding this monopotassium tartarate, so it undergo fertilization. So fermentation process, not fertilization, it is fermentation process during which it will start evolution of, there will be evolution of carbon dioxide gas. So we know that our cakes as well as bread, pastries, all of these are fluffy food, right? It is so soft and fluffy. It's all because of the presence of carbon dioxide gas there, which is released during the reaction, during the fermentation process. Okay. Moving to the next question. Which of the following has the same monomer unit? Nylon and cellulose, polyester and nylon, rayon and nylon, cellulose and rayon. Okay, let us look at the right option. Right answer here is cellulose and rayon. Okay, these are the two different compounds which has, okay, these are the two different components which has the same monomer unit. Okay, when we are looking at the cellulose as well as rayon, cellulose is a natural product, natural one that we will get it from the plants, right? It is a polymer of D-glucose. Okay, there is a presence of D-glucose, whereas this rayon is manufactured regenerated cellulose fiber. So from this cellulose, we will get this rayon. Okay, so cellulose is the one which we will get it from the plants. Okay, natural fiber. Along with that, rayon. Okay, rayon also has the same monomer because we will extract this from cellulose itself. So once we extract, basically rayon, we will get it from the wood pulp. Okay, the tree's wood pulp. There we will extract some of the cellulose, which we will chemically process it. So finally to convert the same into a fiber. And this processed fiber, which is chemically processed fiber, by using the natural raw material, that is the cellulose, we call it as a rayon. So here rayon is the one which is also known as artificial silk because it has the exactly same properties as that of the natural silk. Okay, and also it is semi-synthetic fiber because we are not completely making this rayon out of the chemicals. So we are using the wood pulp and chemically we are processing it, right? Natural one is the wood pulp. Some of the chemicals are added to process that. So we can consider the same as semi-synthetic fiber. Okay, now when we are looking at the monomer unit of this nylons, basically here in this nylons, they are polyamides. Okay, they are polyamides. So amide group will be there, whereas this polyester, okay, polyester that we have here, polyester are polymers of alcohols as well as carboxylic acid. So alcohol group will be there. Along with that, at its one end, there is attachment of carboxylic acid. Okay, so finally we will get this polyester. So out of all of these options, we have these two which are the same monomer unit, that is D-glucose. D-glucose is a monomer which is used here in, which is present here in cellulose. Glucose is a monomer. When we are combining this glucose unit, one glucose unit with the next one. So finally to form a long chain, there is a polymer. Finally it becomes a polymer. So this is the one which is actually present here in cellulose. Okay, it is a polysaccharide unit. Moving to the next question now. Which one of the following substances is made from natural raw materials? Rayon, nylon, polyester, polystyrene. Okay, let us look at the answer. The right answer is option A, rayon. I was just telling you about this. Rayon is the one which we will make it from naturally occurring cellulose. That is, we will extract it from wood pulp. Okay, we will take this wood pulp, one of a natural product. So out of this, we will chemically process it in the laboratories. Okay, once we process this, we will get this rayon. And rayon is also known as artificial silk because it has the same properties as that of artificial silk. So that is natural silk. Okay, it is usually lustrous, harder, strong, long threads, which we can convert it into silk fabric itself. Okay, more or less it looks like a silk fabric, natural one, because its properties are same as to that of the natural silk. Okay, but here nylon is the first synthetic fiber. So rayon cannot be considered as a complete synthetic fiber because it is semi-synthetic, since we are using that artificial source and chemicals are also added to this natural source, right? Natural source, that is the wood pulp, but nylon is made out of chemicals completely. So this is considered as the first synthetic fiber. And even here polyester, it is completely synthetic fiber. Polystyrene is one of a group of polyester. Okay, so all of these are completely made out of the chemicals, but this rayon, so from the natural source which are chemically processed, so this can be considered as semi-synthetic fiber. Okay, semi-synthetic fiber. Now moving to the next question, which substance is used to retard the setting action of cement? Calcium oxide, aluminium oxide, so calcium sulfate dihydrate, sodium oxide, and potassium oxide. Okay, let us look at the right answer here. The right answer is option C, calcium sulfate dihydrate, which is also known as gypsum. Okay, this calcium sulfate, where the two molecules of water is added by a process of recrystallization. Okay, by a process of recrystallization, we will add water molecules to that of calcium sulfate to form gypsum. Okay, calcium sulfate dihydrate, which is also known as gypsum. So this is the one which is naturally extracted. We will get this naturally. Okay, and if we are adding the same to the cement, so gypsum is the one of a component which are mixed with that of cement. Okay, cement clingers to retard the setting of cement. Okay, when we are adding this gypsum to the cement, it retards the setting of the cement. So cement will not usually get dried up. Okay, but when we are exposing this gypsum directly to the atmosphere, it reacts with the oxygen there to get reduced, right? So it will get converted into POP, that is plaster of Paris. Okay, that is the reason gypsum has to be covered airtight and we have to place it. So whenever it is reacting with the oxygen, it will get converted into POP, plaster of Paris. Here the gypsum is the one which is added to the cement to retard the setting of the cement. Okay, we have to slow down the reaction of the cement. So that is the reason gypsum is also added to the cement, one of a component of the cement. Moving to the next question now. Which of the following will be suitable for coating dress materials of fireman? Nylon, polyester, melamine, acrylic. Okay, let us look at the right answer. Here, the right answer is option C, melamine. Melamine is a material. It is one of a thermosetting plastic which is used here in coating the dress materials of fireman, the uniform of fireman. Okay, because this melamine has some of your properties which will usually interfere with the combustion in many different ways. Okay, usually when there is a fire accident, usually firemen are the one which will go there, which will work there, right? So their uniform are usually coated with melamine. Okay, this uniform is coated with melamine here. Melamine is one of a thermosetting plastic. Okay, it is an example of thermosetting plastic which has a capacity which has one of a major property of resisting fire. Okay, it will not easily catch the fire, and this property is actually required here in the designing the uniform of fireman. So here the melamine is the one which is used here in the uniforms of fireman. Okay, it can withstand high temperature. Even if the fireman wearing this uniform, if they get near to the high temperature, it can resist the temperature, and it also corrosion resistant. Okay, it will not easily get corroded. The melamine particle which are using here to make this uniform, it will not get corroded easily, and it is also easy to handle. Okay, these are the major properties. That is, melamine is the one which can resist fire. There is a melamine, easily it will not attack the fire. Okay, the designing of this uniform. So melamine is one of a layer which is used to coat dress materials of firemen. Moving to the next question now. When hot water is placed into an empty water bottle, the water keeps its shape and does not soften. What type of plastic is the water bottle made from? Thermoplastic, PVC, polyurethane, thermosetting. Okay, let us look at the right answer here. The right answer is option D, thermosetting plastic. Okay, here the bottle which we are using it to place the hot water. Okay, the bottles which even though to this bottle, if we are placing this hot water, if we are adding hot water to these plastic bottles, usually it will not melt. Okay, it will not even change its shape, even though if you are adding hot water, because it will not become softened. So only when it becomes softened, it will change its shape, right? Because here the plastic that we are used to make this hot water bottles, the bottles, it will not change its shape. It will not become softened, so it doesn't change its shape, because the type of the plastic that we have used here to make these bottles are thermosetting plastic. Basically, there are two types of plastic, thermoplastic and thermosetting plastic. Okay, thermoplastic are the one when we heat, on heating, we can change its shape because it will become softened. Okay, even though once we made a bottle, if we have a thermoplastic bottle, even though if we have designed a bottle, molded bottle, even though if we are heating this, it will change its shape on melting. But this thermosetting plastic has a property that once it is molded on heating, again we cannot heat it to mold it back. Okay, once we give this shape to this thermosetting plastic by molding on heating, again we cannot change its shape. Okay, it will not bend easily, even though when we are heating it again. So this is one of a property of thermosetting plastic. And whenever we are using the bottles which are made out of thermosetting plastic, even though if you are adding hot water to that, it will not change its shape because it will not melt there on adding hot water. Is that clear? So now PVC. PVC is nothing but polyvinyl chloride. Okay, PVC is one of an example of thermoplastic. Polyurethane. So even polyurethane is one of an example of thermoplastic. These two are the different forms of thermoplastics which will usually deform on heating. Okay, but thermosetting plastic or the plastic which will never deform once it is already molded. Got it? That is one of a property that we have to remember. So once heated, it becomes hardened as well as strengthened. So after cooling, but again, we cannot change the shape by heating. Moving to the next question now. Alum is used as an analgesic, a fertilizer, a disinfectant, a purifier of water. Okay, let us look at the answer here. The right answer is option D, a purifier of water. So usually this alum is added to this water because this is the one which usually it has a property to coagulate mud particles. That is, it will combine with the water and increases the rate of sedimentation process. There in the water treatment plant, usually alum is the one which is added to the water during purification process, because if there is any solid particles, solid undissolved particles in the water, it increases the rate of sedimentation process. Okay, in a beaker, if we have muddy water, okay, the soil water, completely in mud water. So when we are adding alum to this, it increases the rate of sedimentation. So all the solid particles which would have not dissolved in the water will come and settle at the bottom of the beaker. So that by a process of decantation, we can easily separate the water, clean water from that of the sediments. Okay, so that is the reason alum is used here in purifier, as a purifier for water. Moving to the next question. So here we have a picture of alum. Okay, it is a substance called alum. In chemical terms, what are alums used for purifying water for drinking purposes? Hydrated chlorides, double nitrate, double sulfates, nitrates of aluminium. Okay, let us look at the right answer here. So the right answer here is option C, double sulfate salts. Okay, here in chemical terms, the alums are made out of, okay, it is used for drinking purpose because they consist of double sulfate salts. So these double sulfate salts having a composition of X, okay, let us consider this as X, aluminium sulfate. Here the component that we can include it as aluminium. Okay, so aluminium sulfate, 12 hydrated. Okay, it is hydrated molecule here. Aluminium sulfate hydrates. So when we are looking at this here, okay, this is general formula that we have for this alum. And here the X that we have here, it stands for monovalent cation. So this is the chemical nature of this alum when it is mixed, when we are mixing this with that of the water when during purification process. The X that we are using here is the monovalent cation such as potassium or ammonium. Okay, here we can use this potassium salts or ammonium salts, which are double sulfates. Okay, aluminium sulfate. So here we have double sulfate group. It is the double sulfate salts that we are actually adding to the water during purification process. Okay, that is the main composition of this alum. And alums are the one which are used in purification of the water. So alum consists of double sulfate salts. Here the X is nothing but as that of the monovalent cation. So here the monovalent cation that can be used here are potassium as well as ammonium. Any one out of this can be used for purification process of water. Okay. And students, in this class we have learned about organic chemistry. Under that we have covered about hydrocarbons biomolecules. part 2, right? So we have covered most of the major important questions that we can cover regarding the topic hydrocarbons and biomolecules. Thank you for attending the class now.